Welcome to a lesson with Dr. Powell. Let's talk a way of solving a system of equations that involves adding equations together. Call this elimination. Now, why are we calling it elimination? Because we're going to be eliminating one variable at a time. When we eliminate one variable, we change this system of equations. So this is a system of equations with two unknowns and two equations. So there's two unknowns. I'll kind of say this in this direction, maybe just kind of on this side of the equal sign. We have two unknowns and we have two equations. So when we have a system of equations, normally we say we have something like we have two equations by two unknowns. We call that a 2-by-2 system. And not only, and if the powers and all the variables here are just one, and we don't see anything crazy or fancy like this, we just see multiples of a variable plus multiples of another variable, then we call this a linear system of equations. So we would call this a 2-by-2 linear system. So kind of the natural idea is to start with a 2-by-2 linear system and then reduce that system to a 1-by-1 system by using the assumptions that both of these equations hold. Somehow we can change the system to a 1-by-1 system, linear system. Now, what does that mean? That means one equation, one unknown, and it's linear. That should be pretty easy to solve. Then once we get that, then we backtrack to the 2-by-2 linear system and get the value of the other variable by back substituting in the result that we got in this 1-by-1 system. So that's kind of the idea. And we're going to be expanding this to 3-by-3 systems in another video. But for now, we're going to think about elimination. We're going to be eliminating one of the variables so that we drop from a 2-by-2 system to a 1-by-1 system. And we're going to be doing that by adding equations. How does that work? Well, right here in this system of equations, if we assume that both equations hold, then we assume that this value is the exact same thing as 4. So adding 4 to both sides of this equation would be the exact same thing as adding this to this side and this to this side. Naturally, we can add equations and still have an equation. Now, but we want to do this in such a way that one of the variables is eliminated. How do we do that? Well, here's an example. What if we were to multiply the bottom equation, that means both sides of the equation, by -2? Then the bottom equation still is an equation. And in this case, it'll actually look like -2x plus 2y minus 8. Why is this nice? Now, if we add the two equations together, notice we get 2x plus -2x. That cancels to 0. We've been successful at eliminating one of the variables. Now, the result in the addition process will be a 1-by-1 linear system as desired. So we add, we get 5y is equal to 10. So y must be 2. We're successful at solving the 1-by-1 linear system, which was actually just this. Now, upon getting the y equals 2, we can back substitute into one of the equations we began with. Now, we began, see this equation, I had changed form, but remember what I did, I multiplied -2 to it. Let's just look at what that equation was originally. It was x minus y, I think, because if you multiply negative, it's +2. And then here, that must have been +4. And I can just double check. 2, 8. Yes. Okay. That looks good. Okay. So this was that equation. That means I can plug this 2 back in here. And I get x minus 2 is equal to 4. So that means that x is equal to 6. So then I have my solution to my system as just being 6, 2. Notice that there's only one solution. For a linear system of equations, think about what's happening. Both of these are like straight lines. Straight lines, when they intersect in one place. Or if they're the exact same line, I guess it'd be the same everywhere. And so every single point on one line is a point on the other one. Or you could have the condition when they're just parallel to each other and they don't intersect at all. So really there's like one solution or like infinitely many or no solutions. So here we found one solution and we did it by the process of elimination, meaning we took one of the equations and multiplied it by something such that when we added it to the other, one of the variables canceled out. We tried to make the coefficient of one guy be the negative of what the guy over here was, so that when we added, it canceled out and got 0. So then we got a 1-by-1 system, which we could solve. Then we substitute that back in to one of the equations we have up here to figure out what x should be. And then we have our solution. We could double check just to make sure both equations hold. This equation holds apparently. Now plugging back up here, 2 times 6 is 12, plus 3 times 2 is 6, that is 18. Thanks for watching.